Today, I'm going to introduce and present our work entitled Convolutional Neural Networks for Multimodal Brain MRI Images Segmentation, a comparative study, made by our team constituting of 3 members: me, Hisham Mujahid, PhD student at SSDIA Laboratory in Set Mohammedia, Hassan the University of Casablanca, Professor Bushaib Sharadi and Professor Hussein Bahati, professors at same university. So let's go to the plan. Firstly, first of all, we are going to introduce the brain tumor segmentation problematic and its relation with convolutional neural networks. Second, we will introduce the artificial neural networks concept and presentation of convolutional neural networks methodology. Third, a comparison of some interesting CNN models based on their performance and prediction precision. At, at the end, we will conclude making a short conclusion by listing the main limitations facing researchers developing methods of segmentation task. So, introduction. Here, malignant brain tumors still the second biggest cause of death in the world for patients between 15 and 34 years after heart attacks. Therefore, the early and accurate diagnosis is very important to get an efficient treatment and save patients from death. This task requires a deep analysis of MRI images of brain to achieve an accurate segmentation by medical experts. Here we have two methods of brain tumor segmentation: manual method and automatic method. For the manual method of brain tumor segmentations, it still the most efficient approach and usually used by radiology experts. The main inconvenience of this method is that it's very linked to human mistakes, and it's a laborious and time-consuming task. We have here an automatic segmentation or automatic methods of brain medical images segmentation as still a challenging problem for scientists. But recently many researchers become interested in artificial neural networks, especially convolutional neural networks, to achieve medical image segmentation tasks as an automatic way. It enables machines to solve complicated pattern recognition problems and extract objects from images by classifying a classification process using the ability of CNN models to learn from large datasets. About methods, there is artificial neural networks concept that is inspired from the biological brain, which is the most complicated smart system that processes data received from the 5 senses in the body. The processing ability is obtained from synapses in the form of a conception between large amounts of biological neurons forming a huge neural network, able to process a lot of complicated operations. Convolutional neural networks CNN is a subclass of ANN network, most commonly applied to analyze image and video contents. As its name indicates, a CNN is an ANN network containing at least one convolutional neural network. Here, the architecture of a CNN blocks. So at the input layer, we have an image of a brain tumor. After that, we proceed for feature selection and feature extraction and selection. Then we get through convolution layers with activation relay, then pooling, then convolution with relay, then pooling, and all layers between convolution and pooling are intermixed each with other before entering into fully connected layers specialized on training tasks. At the end, we have here an output layer with the dimension of the classes of the task. So the methodology is for brain tumor segmentation with CN is as follows. Pre-processing, it's about image pre-processing, cropping or contrast, resizing, and everything related to the input dataset processing. Then features extraction and feature selection, which consists of extracting only useful data from the dataset. Then it comes the training the training step, which is achieved through this step by minimizing as much as possible the loss function over iteration and maximizing the accuracy function. Then validation and testing. This step is to determine the performance of the network by calculating the error function using a minimized dataset. Then a classification, which consists of joining images to labels according to the calculated probability, and the post-processing is the last step, uh, which is uh, generating over segmented regions like superpixels for obtaining the final segmentation results. So the comparison, we have here EMA model, which is the winner of a BRAS 2017, obtaining the following results: 73.8% for enhancing tumor, 90.1% in the wall, and 79.7% in core. And it is constituted with 5 other models, 3 of 3D FCN model and 2 of 3D unit model. Here, a second model is CNN-based segmentation of medical imaging data, and it's the winner of Pratt's 2015 and ITL's competition or challenges, where results are 61%, 85%, and 72% average dice for enhanced wall and core tumor respectively. And it constitutes with personalized units in an architecture by combining multiple segmentation maps created at different scales or using element-wise summation to forward features maps from one stage to the input to the other. The third model is autoencoder regularization based, and here we have 76% of enhancing tumor, 88% in the wall, and 81.5% in the core, and is the winner for BRATS 2018 and called InfidL MED. It constitutes two parts, encoder part and decoder part. The encoder uses ResNet blocks, where each block consists of two convolutions with normalization and ReLU followed by additive identity skip connection. The decoder structure is similar to the encoder one, but with a single block per each spatial level. Discussion. This presentation gives an overview of several methods for the automatic brain tumor segmentation task using 3D convolutional neural network. As we see here, we have EMA, maximum accuracy in wall tumors, and we have NVLT LMAD, which is the last model with 76 in enhanced tumor and 81.5 in tumor core. As we see here, we have the best models are EMA and NVLT LMAD. So as a conclusion, brain tumor segmentation presents a very challenging task. For researchers all over the world, many laboratories propose each year new methods for automatic segmentation of brain tumors to surpass the limitations presented in the previous methods. However, the main constraint that faces those methods and needs a lot of development is processing capacity, due to the constraint of training neural networks with an extensive number of datasets to improve predictions and reduce errors, especially when classifying and segmenting the 3D MRI images of brain tumors. Thank you for watching.